I'd like to shift gears a little bit and move over to talk about the Conservation Tech Award that we just wrapped up. So about a year ago, maybe, we were talking internally about the Locust project, actually in Kenya, that I think you'll hear more about in the coming days. And Jody Allen, Paul Allen's sister and the chair of our board, was really excited about this and said, well, that's really cool. Can we create a award to celebrate really creative uses of conservation technology? And so out of that was born the CTA. So this was developed to encourage people to get involved in conservation technology, reward people who have done really innovative things, and also to inspire people about what's possible and the potential and hope that comes from a lot of these programs. So we created two awards because we didn't want this to just be tied to EarthRanger. We wanted it to be broader than that. So we said we'll give away two of them, one to a member of the EarthRanger community, one to broader community and conservation tech, each for $15,000. We put out a call for applications. We received about 100 of those from, let's say, 6 continents and 32 countries. So, really broad interest. We really weren't sure what to expect. So we were really thrilled at this. And the applications themselves were phenomenal. There's so many people doing really, really interesting things all over the place. We put together a committee to judge these. I think we had 9 people. I don't have the full list here, but we had representatives from Microsoft, Google, Smart, WCS, Alina, who's here somewhere, from Grimeti. Many people, I apologize for the people that I'm leaving off, but really appreciate all of their participation in this as well. We read through 100 really amazing applications, narrowed it down to about a dozen different applications that we selected as finalists. And so I do want to put up the names of these organizations as honorable mentions, who we were all extremely impressed by. But there were 2 that really stood out, and just across the board among all of the judges, we were all just really blown away by 2 in particular. And so really happy to announce, although technically announced on social media a couple days ago, but I'll announce here, the first winners of the Conservation Technology Award, who are the Giraffe Conservation Foundation and Lion Guardians. So I'll pause there for applause. But and you'll hear more from each of these folks. I'm going to play a video here. I'll start with Lion Guardians because unfortunately, I should have this here. 3A. Fortunately, they weren't able to join us in person, but we do have a video here. So I'll start there. So the Lion Guardians won the award for non-EarthRanger user, and then threw in a wrench by a couple months later becoming an EarthRanger user. So we had good intentions, I assure you. But let me play that video.
Hello, I'm Nadia, and I'm Lion Guardians' research scientist. Lion Guardians is a conservation organization, and our mission is to promote the sustainable coexistence between lions and people through the inclusion of communities, cultural values, and science. At Lion Guardians, we work in the southern region of Kenya in the Amboseli ecosystem, which you can see behind me is very beautiful. And we also have partners across the world, including Zimbabwe, Tanzania, Rwanda, and even India. At Lion Guardians, we use science and technology, and we blend this with traditional knowledge. We work with traditional Maasai warriors whose skills are honed towards tracking lions and knowing lion behavior. They use technology to bolster these skills. For example, they will use low-tech, like cell phone technology, to call communities and inform them about lion presence so that they can avoid taking their livestock to those areas and prevent further potential conflict. we also have and use high technology. We've developed an AI-driven lion identification software and database called Link. So we are super excited to have won this grant from EarthRangers in acknowledgement of our work, and we hope to use it towards furthering our use of technology in the field. We want to implement new tracking technology to monitor our naughty lions so that we know exactly where they are. And we want to also upgrade our data capture methods and further develop our knowledge sharing application. So thank you so much to EarthRanger, and we look forward to our journey together.
She's not here, but I'll clap anyway. And then among our existing EarthRanger group, I'm very happy to introduce Michael Brown from the Giraffe Conservation Foundation. I think I haven't really hidden my my own personal bias for giraffe very much among the group, but so I was thrilled to see their submission in this, and we've been working with Michael and team now for 2 years, I think, on some of their work, and so really excited to introduce Michael and hear about the Giraffe Conservation Foundation's work. So thanks, Michael.
Thanks, Jess. Good morning, everyone. It's really, I'm humbled to accept this position or accept this award on behalf of the Giraffe Conservation Foundation. I'm Michael Brown. I'm a Conservation Science Fellow with GCF and the Smithsonian Conservation Biology Institute. And it's really a great honor to be acknowledged alongside great organizations like Lion Guardians, and to have the pleasure of speaking with you all this morning. Before we jump into things, I just want to acknowledge how nice it is to be able to see you all face to face. I've had the privilege of emailing with you and seeing you in sort of the two-dimensional realm a lot over the last 2 years, and it's really, really great to speak with you face to face. I'm excited for engaging in conversations, and so I want to thank the EarthRanger team for putting this all together and having the opportunity to speak with you all. Coming into OR Tembo yesterday, it was really great to see everyone. As we were walking out of the departures, though, I was taken aback by the number of giraffe I saw in the curio shops and on the posters in the wall. I've been studying giraffe for almost the better part of a decade now, and it still surprises me how iconic these animals are and how beloved. But really, I don't think that should come as any surprise, because this fascination with giraffe is not a new human phenomenon. Humans have been sharing space with giraffes since before humans were humans. Giraffe, as we currently know them, appeared in Africa between 1 and 2 million years ago, whereas Homo sapiens are relative newcomers, arriving roughly 200,000 years ago. But in those hundreds of thousands of years of shared coexistence, we've long admired giraffe. We studied their unique history through tracking and captured their unique anatomy through ancient rock carvings like this one in Tweefelfontein. We've admired their ecology and the role they played in the same ecosystems that nurtured us as a species. But despite this long relationship with this iconic animal, there's still so much we have to learn. And the need for this knowledge is becoming increasingly more urgent. Throughout the giraffe's range, the landscapes are changing at an unprecedented rate. Giraffe are facing increasing challenges of urbanization, road, railway, fence development, oil development, encroachment with livestock, and illegal hunting. It's sort of the standard suite of conservation threats I'm sure many of us face. These diverse and varied threats require us to develop ecological understandings of giraffe at spatiotemporal scales beyond what our ancestors may have imagined. You see, giraffe are widely distributed across 21 different countries in sub-Saharan Africa. Throughout their range, their populations have experienced substantial declines over the past several decades. By our best estimates, and this is from a paper that was just published about a week and a half ago, there's currently 117,000 giraffe remaining in the wild. The IUCN, which as of the 2015 assessment categorized giraffe as vulnerable, but recent genetic work co-authored by my colleagues at the Giraffe Conservation Foundation provides strong evidence in a shift of this taxonomic categorization, which would divide the one species of giraffe into 4 separate species of giraffe, all of which face some sort of conservation threat. As you can see, the distribution of giraffe covers a diverse array of habitat types, land use practices, socio-political contexts. It's an incredible diversity, which necessitates diverse approaches to understanding and conserving them across the continent. So giraffe inhabit landscapes from the rugged savannas of northeastern Uganda to the barren pans of Etosha National Park, to the Rift Valley Escarpment in Lake Manyara National Park, to the shadows of Mount Kenya on the Laikipia Plateau, the acacia woodlands of Murchison Falls National Park in Uganda. They live in these diverse landscapes, each with unique challenges and unique conservation opportunities. So there's no one particular conservation silver bullet that'll work for giraffe everywhere. But the key is in identifying ecological touch points, remaining flexible enough where we can adapt our strategies for specific needs in specific locations, while having the vision at the continental scale to collect data in a way that's comparable across sites. So we can develop principles and theories in giraffe space use, giraffe population ecology, which can be applied broadly to all of the sites we currently work. So to ensure a sustainable future for these animals and to figure out a better way to coexist with them, we need to develop strategic understandings of giraffe ecology across scales. By harnessing the latest technology, with cutting-edge scientific methods and combining them with intimate understandings that can only be developed through boots on the ground ecology and local partnerships, the Giraffe Conservation Foundation is pushing the boundaries of data-driven conservation action. So that brings us to the Giraffe Conservation Foundation. GCF is a small and diverse team, but we like to think we have a relatively large impact. We currently operate or support projects in 16 different countries. These projects include community conservation initiatives, running environmental education programs, conducting anti-poaching patrols, providing veterinary support, conservation translocations, and of course, what I'm here to talk about today, technical support and conservation science. We do this all as a relatively small team. Currently, we're a diverse team of about just over 20, based in 6 different countries, comprised of 16 different nationalities. And we all have diverse areas of expertise, from accounting to project management, to conservation science, to veterinary support. So we work really hard to achieve these ambitious scientific and conservation goals. But like many of the organizations here, we augment the impact of this small group through strong collaborations with key partners, a lot of who are in this room currently. Working with these partnerships and leveraging local and technical expertise, we want to push forward these shared agendas. And of course, we also work very closely with the dedicated rangers, scientists, communities, administrators working hard in the landscapes where giraffe live. Their contributions to giraffe conservation are immense and cannot be overstated. It's truly a privilege to work alongside such dedicated folks in the field. Now, working with all of these partners together to push conservation or data-driven science, data-driven conservation, we need to develop solutions to produce rapid data, analyze it quickly, and disseminate it to our partners so that we can act on it in real time. So with that, I'd like to spend the remaining time here focusing on some of our applications in conservation. The advances in conservation technology that we've seen over the last decade. I'm sorry, it's windy. Yeah, it was windy there in northwest Namibia. They offer new opportunities to link animal movement and population dynamics to landscape level processes. But these increasing data volumes require new data management tools and analytical frameworks to apply this information to ecology and conservation studies. So with that, I want to focus on 2 particular initiatives that were highlighted in our application and that we use as sort of the backbone of a lot of our conservation science. The first of which are individual-based photographic surveys using computer vision and pattern recognition software. Like a lot of species out there, I know there's some folks who use these techniques. Giraffe have individual spot patterns. We can tell them apart as unique individuals based on their spot patterns. It's almost like a name tag. So conducting photographic surveys where we essentially drive these routes or use camera traps, or increasingly now potentially aerial surveys, we're able to identify individuals. And depending on the conservation needs of each protected area, we design specific studies to address key elements in population dynamics and spatial distribution. But this all requires us to match these patterns against existing databases so we can identify them as individuals. As you might imagine, trying to manually match spots of giraffe in photographs, and some of these giraffe populations, which number in the thousands, would take a really long time. And in the past it has. But this is where we rely on some sophisticated computer vision and pattern recognition algorithms. With some of the computer developers, with the Giraffe Spotter program and the Wild Me folks, we've worked to create and implement specialized pattern recognition software, which allows us to take a photograph in the field, extract giraffe from that image, extract the pattern from those giraffe, and match them against known databases. So we can effectively get the name of every giraffe we encounter in the field. Over time, through repeated surveys, we can piece together individual histories of thousands of giraffe. And over the years, we literally watched individual giraffe grow up, like this one here in Murchison Falls National Park in Uganda, who in December of 2017 was a gangly subadult male, but over the next 3 years, we watched him progress into a robust young bull. We can follow up on specific individuals, ones that have been treated with veterinary interventions, ones that have been desnared, but we can also combine these data sets and the narratives of all of these thousands of unique giraffe in these specific populations to get a much better understanding of population dynamics and spatial distribution. Utilizing multi-state capture, recapture, and spatially explicit capture, recapture analytical frameworks, we can look at metrics like population growth, how the distribution changes over time, what potential threats impact giraffe survival, what kind of group structure and social dynamics these giraffe have, how are populations responding to conservation initiatives like habitat restoration or corridor preservation, and how do projects like road construction or mining impact all of these potential population level processes. Surveys like these provide extraordinarily valuable data for knowing how to best target and manage conservation initiatives. And having the technology like this computer vision and pattern recognition has decreased our workflow from weeks to days, making these data much more useful and relevant to time-sensitive conservation initiatives. And we've employed these tactics across a number of different sites. We currently have a database of just about every single giraffe in Uganda, all the giraffes in northwest Namibia, and several other key conservation landscapes throughout Africa. So this is a really valuable and useful tool for rapidly assessing abundance and distribution trends. With the rest of the time, I want to focus on our TweekaTracker Initiative, which is a program that actually brought us to EarthRanger in the first place. The TweekaTracker Initiative is an ambitious conservation research program designed to develop deeper understandings of giraffe spatial ecology and movement decisions across those diverse habitat types that I showed you earlier. Over the past 5 years, a growing network of research partners spearheaded by the Giraffe Conservation Foundation has deployed nearly 300 specially designed GPS units on all species of giraffe across 11 different countries. Unifying the understandings of giraffe movement ecology and space use requires systematic analyses of these diverse ecosystems. Furthermore, data collected from these studies are instrumental in guiding giraffe conservation throughout their range. So with each program, each area, we deploy some of these GPS units. We try to look at it in this hierarchical structure where we need to meet 3 specific goals. One, we liaise with the partners on the ground to develop site-specific management priorities. How can the data we're collecting on giraffe be applied immediately to conservation action on the ground? 2, we look at site-specific research objectives. What are the unique characteristics of each of these ecosystems which can teach us something new about how giraffe interact with their environment? And 3, we're looking at continental scale movement ecology studies. How can we define our protocols so that we can combine data from across these different sites to get mid-range theory on giraffe movement ecology and browser space use at the continental scale in these incredibly diverse environments? All of this requires us to track giraffe. So the question is, how do you track a giraffe? And the short answer is very carefully. Giraffe have a unique anatomy, which makes them unsuitable for some of the traditional methods for attaching GPS devices. They have a unique physiology, which makes them difficult to immobilize. And they're large, highly mobile animals, which makes them difficult to track in some of these very remote landscapes. And so with all these challenges in mind, this first step was designing and developing the appropriate giraffe tracking technology. And this has been quite a journey over the last decade or so, and it's one that we're not completely done yet, with, but we've developed a suite of different tracking technologies with a lot of the manufacturers, some of whom are here, savanna tracking, African wildlife tracking, series tags to try to develop head harness systems, ossicone mounted units, ear tags. We're recently deployed some tail mounted units to develop minimally invasive giraffe tracking technology that can meet our needs and collect the data we need to track giraffe across these diverse landscapes. Step 2, attaching these tracking devices to giraffe. To put one of these GPS units on a giraffe, you must first capture the giraffe. I put this picture here. It's sort of the standard operating procedure for capturing a single giraffe. After a dose of a chemical immobilizing agent, the capture team here, 2 Uganda Wildlife Authority rangers, will rope the giraffe to the ground to bring it down in a more controlled manner. I include this slide not as a gratuitous game capture image, but as a way to highlight the stressful nature of these operations. It's stressful for the animal, it's stressful for us, it's expensive. And so we have a moral and ethical obligation to maximize the utility of any data coming from these operations. And we take that responsibility very seriously. And step 3, developing data sharing platforms and analytical frameworks. And that's where programs like EarthRanger come in. To date, we've deployed nearly 300 units across 11 different countries, all 4 species of giraffe, nearly 2.5 million different data points collected. And so from a data management perspective, trying to manage this many units on this many landscapes in real time is logistically really, really challenging. And so we are looking for solutions to incorporate all these data and analyze them in real time so we can best inform conservation. And that's where EarthRanger came in. EarthRanger has provided useful tools for large-scale movement ecologists to get a handle on some of these data challenges. We still do a lot of the heavy analytical lifting and some of the beefy science and R and other GIS programs, but for the day-to-day management of these data, EarthRanger's proved incredibly valuable. So to get the immobility alerts in real time and quickly mobilize crews to check on irregularities, using Tableau to look at voltage profiles in some of these units to see if we need to reprogram them to prolong their lives. We also want to highlight the ability to ingest data from multiple sources. That's proven critical. As we saw earlier, having different manufacturers providing different devices, it's difficult to manage all of these data, and having one platform that can ingest all of them has saved us a lot of time and effort. The EarthRanger to EarthRanger sharing, as Jess mentioned earlier, we've adopted with a lot of our key partners, Kenya Wildlife Service, Uganda Wildlife Authority, to help share these data with the managers in each of the parks and provide access. It's been a really useful tool, and we really value that instant sharing of data. The data visualization is one of the more simple applications, but being able to look at the locations in real time and rapidly share this with partners has proven really invaluable. Looking at geofencing applications as well has been an extraordinarily useful application. The ability to easily program these geofences has enabled us to identify when giraffe are traversing international borders or crossing protected area boundaries, allowing some of the rangers to potentially go out and mitigate some of the conflict with communities surrounding these areas. From some of the other management applications, it's been extraordinarily useful in following up on translocated giraffe. Having a mobile app for rangers to use in the field has been really, really useful to allow them to find these animals in these large landscapes and check on body condition after they've been released to make sure that they're adapting well to their new environments. It's also been extraordinarily useful for some of the routine monitoring in some of these remote systems, providing targeted areas for our field teams to use these apps in real time to identify which canyons in Northwest Namibia they need to drive down and which ones they can avoid. And we have field testimonials from each of our teams in the field attributing the value to these programs. Additionally, this is one of the newer developments. The EarthRanger program has been really useful for developing outreach applications. So recently we've been working with the EarthRanger team to develop public-facing maps, allowing us to share these locations of these giraffe in near real time. We delayed it for security reasons, but have a public-facing map so folks, a wider audience can access these data and learn about the narrative of each of these giraffe and these diverse habitats to hopefully promote engagement and conservation interests with wider audiences. From a science perspective, this program has been extraordinarily valuable. Although it's still relatively new, We've published over 10 peer-reviewed articles, and we have quite a few more in the pipeline. From a policy perspective, these data have been extraordinarily useful. One of the major initiatives with the Giraffe Conservation Foundation is to develop national conservation strategies for range states. And through stakeholder engagement workshops, we've been able to share the data that we've collected through these programs with key stakeholders to help define conservation initiatives and put together roadmaps for giraffe conservation in several key range states, Uganda and Kenya being highlighted here, that outline giraffe conservation initiatives for the next decade or so. And then, of course, the conservation applications themselves, using data collected from the photographic surveys and the color data, we were able to assess the feasibility of certain conservation translocations. And that's been really instrumental in guiding one of Giraffe Conservation Foundation's key programs, which is reestablishing giraffe populations in areas where they've been extirpated. So here you saw giraffe being released in Pianupe Wildlife Reserve in Kenya, or Uganda, excuse me, back in 2019. And just to give a mark of this success is when we began our work in Uganda with the Uganda Wildlife Authority back in 2014, there were 2 populations of giraffe. Currently, there's 5 separate populations of giraffe, and data collected from these programs has been instrumental in guiding those initiatives and providing the right technical support to make these decisions. So a way forward for science-based conservation of giraffe. I mean, it starts today, and I'm really excited to have the opportunity to hear from you all about the wonderful applications that you're using EarthRanger for, and trying to adapt and change them and modify them to inform our own efforts. So I'm really excited to have the chance to engage with you all and discuss these with you moving forward. And again, I want to thank the EarthRanger team for putting us together and giving this forum for having these conversations. So thank you very much, and please look forward to talking with you guys in the interim.